Good day to everybody. My name is José Vicente Oliver. I am professor for forest bioeconomy and engineering at the Technical University of Valencia, inside the Ithaca Institute, and also director of the research group ICT Against Climate Change. That means Information and Communication Technologies Against Climate Change. Today, inside the European project IMIP, that means Innovative Eco-Construction System based on interlocking modular insulation, wood and cork-based panels, I will give a lesson about the enhanced use of wood in construction based on sustainable forest management. I am also the coordinator of this project. My presentation will have three parts. The first is regarding sustainable forest management. The second is forest bioeconomy towards sustainable wood construction. And the third is the research challenges we have in the southwest area of Europe, the SUDOE area, for sustainable wood construction. So if we could begin about sustainable forest management, we have to go back to 1730 with Hans Carl Karlovich publishing his book about Silvicultura Economica. That means the first publication regarding forest sustainability principle. Von Karlovich was a mining engineer working in southeast of Germany, in Saxony, and he has, deforested quite a large area in order to harvest wood for the building of the mines in this area. And taking into account and knowing that the forest was growing, he thought about the possibility to plan not more harvesting, that growing, and that was the principle of sustainability. And in this book, we have to take into account that we are speaking with the language of the 18th century. Von Karlovich said, for the protection and cultivation of wood, a lot of art, science, and effort are required to ensure a continuous, permanent, and sustained use. And here come the word sustainability, what in German is Nachhaltigkeit. It is an inalienable issue without which the country, in its essence, will not be safe. When forests are ruined, income is lost for many years, and von Karlovich spoke about 50 to 100 years, ruining the treasury, leading to an acceptable short-term profit, but masking a loss that cannot be replaced. So, von Karlovich described as first technician the principle of sustainability, but we have from this beginning of the 18th century until today different milestones in the development of the principle of sustainability. Sustainability was at the beginning related strongly with the sustainable management of the natural resources, in this case especially with the forest resources. But coming to the 20th century, we began different publications and different new ideas about sustainability that began maybe with the famous book of Carson, 1962, about the Silent Spring, over the Ramsar Convention about the protection of different ecosystems, 1971, or in the 80s, 1980, with the World Conservation Strategy, and also 87 with the Brundtland Report about our common future. And one very important milestone was the Earth Summit in Rio Declaration on Environment and Development in the year 1992. The Kyoto Protocol 97 was also very important in order to merge what is natural conservation and also the first approaches or the first visions to fight or to tackle climate change. Different international events have reinforced this sustainability principle. Sustainability or sustainable forest management is also quite related to the new policies or the recent policies against climate change. We had, as you maybe know, a lot of different international meetings in the Framework Convention on Climate Change of the United Nations, what is known as the COP meetings, since 1994 with the COP1 to today with the COP26, the last meetings at international level. Very interesting is that especially in the COP26 in Glasgow, we saw the first clear relationship between forestry management and climate change. And in this international convention, there was a very important Glasgow Leaders Declaration on Forest and Land Use. It was in year 21. So that over 140 countries, accounting for more than 90% of the world forest, did this declaration, and in order to work together to halt and reverse forest loss and land degradation at world level with the scope of 2030. 12 countries announced in the COP26 a global forest finance pledge to collectively provide more than 12 billion of US dollars for forest-related climate finance until 25. And here, I think the most important aspect is that the sustainable forest management have a direct, or all one of the results of this event was that the declaration said that the sustainable forest management have a direct effect to help to slow the rate of climate change by removing carbon dioxide from the atmosphere and storing it. That means forestry in the center of climate change mitigation, not only adaptation. Today's definition of sustainable forest management, and here is a definition from the European Agency of Environment, said that sustainable forest management means the stewardship and use of forest and forest lands in such a way and at a rate that maintain their biodiversity, productivity, regeneration capacity, vitality, and their potential to fulfill now and in the future relevant ecological, economic, and social functions at local, national, and global levels, and that does not cause damage to other ecosystems. So, sustainability, forest sustainable management based on the three pillars of sustainability: environmental protection, social and economic development. Today in Europe, sustainable forest management and the tools that we have for doing that, to make it very easy to understand, is normally oriented to two different models. The first model is what we call the intensive silviculture towards the timber production. That means an intensive use of the forest land in order to produce fast-growing trees to achieve large dimensions of wood that can be used especially for forest products or for wood products. That is the model that is very usual in the northern part of Europe, and even here in our area in the southwest, in the SUDOE area, more in the Atlantic area. On the other side, these are combined with another model of protective silviculture towards ecosystem resilience and conservation. That means intensive and very quality-oriented silviculture in order to support and to help the forest ecosystems to be more resilient against natural disturbances. And here in the Mediterranean area, or in our region in Southwest Europe, more oriented to prevent forest fires, but also to enable these major stands, these major ecosystems, to regenerate naturally and to create the new generation of forests through natural regeneration, and not so with afforestation or reforestation that we saw before in the other intensive silviculture model. The result of sustainable forest management during the last century in our continent is shown in this different slides that will come now. If we take a look back at the beginning of the 20th century, in Europe, we had not more than 20% of the territory was covered by forestry. But this have changed very clear during the century. 1910, 1920, 1930, and then we became the Great War, the Second World War in this time. And from then, that means in the 50, 60, and even more up the 1970, we see an increase, a clear increase of the forest land in Europe until our days. We see it especially in the northern part of Europe, that means in Scandinavia, but also in the southwest part of Europe, that means in the Iberian Peninsula and the Mediterranean area. Today, the forest map of Europe shows that we have around 40% of the territory in Europe is forest covered. That is by far more than the average in other continents in the world. If we take a look in the SUDOE area and compare what happened at the beginning of the 20th century and more than 100 years later, that we see that we have incremented quite a lot the forest area in our countries, in Spain, in Portugal, and in France. The areas used for farming in these countries have decreased very clear, while the reforestation, especially in the 50s, 60s, 70s, and also the natural regeneration after different soil uses, or even the colonization of former marginal agricultural land, has increased very clear the forest area in our countries. Spain today, for example, has more than 40% of forest area. Another very important data are what we are harvesting, what is growing in our forest in Europe, and how much we are harvesting in our countries. If we can see the whole figure for Europe, we have an annual growth of wood of around or almost 800,000 cubic meters, or 800 million of cubic meters per year. That is the annual growth that every year or each year the forest is increasing or growing in Europe. What we are harvesting is around 500 million of cubes. That means less than 60% of the annual possibility. That means that in Europe, and maybe with this graph we can understand this better, since the Second World War until now, we have more or less double our annual increment of our annual growth of wood in our forest, with around or almost with the next years 1 billion of cubes in the whole continent. But we are harvesting even less, or around the half of that what is growing in the forest, and we are more or less stable between 400 and 500 million of cubes. So that is clear that we have a room to maneuver in Europe, and we could increase our harvesting rate in order to get more resources, in maintaining by far the principle of sustainability and based on our principles of sustainable forest management. If we focus on one representative region of the Mediterranean area of Europe, for example, our region here in Valencia, the forest cover, actually, at the moment, we have more than 1.2 million of hectares, and the forest cover is almost 60% of the territory. So by far more than the average in Spain and the average in Europe. We have here in our region an annual increase of 3,000 hectares each year. The annual growth is more or less 1 million of cubic meter per year for all the forest area. And in our case, we have a harvesting rate of less than 10%. That means that we have large areas that are unmanaged and that are not harvested. That is very normal for the Mediterranean area of Europe, and that, well, that could have positive, but a lot also of negative aspects. Unmanaged areas could be very vulnerable against forest fires. And if we see here these maps, we can see that high populated areas in Europe with a lot of forestry have also quite a lot of interface between urban areas and forest areas that can also be dangerous for the vulnerability of forest fires. But also the severity of these forest fires could be very important in areas with difficult geographical and orographical conditions, and with meteorological conditions, especially in dry summers and hot summers, to have large forest fires. And that is one of the main perturbance that we could have in order to maintain the sustainable forest management and the conservation of our ecosystems that could be better managed in the future. So that is an overview what we have in terms of forestry and what are the situation or which are the situation in sustainable forest management in Europe, in the SUDOE area, and also in here in the region in which we are in Valencia. The second aspect I wanted to comment with you is the forest bioeconomy and the wood construction. So how is structured the forestry wood chain in order to supply the construction sector with high qualitative products? So if we can see in this figure, with the forest management, we have the wood harvesting activities, and harvesting this wood in the forest, we normally have two large groups of products. On the one side is the fuel wood that is directly used for domestic uses, fuel, especially in the rural areas, but the other large amount of industrial roundwood. This industrial roundwood can be also shared in two large groups. What we can use for sawing material and veneer, that means the saw logs and the veneer logs. And on the other side, the smaller dimensions and lower qualities that are going to the trituration, to the milling, either for pulping or even also for wood-based panels. So these logs and also large dimensions, good qualities, but also small dimensions and lower qualities are transformed industrially in the primary processing industries. And these primary processing industries are the sawmills in order to produce sawn wood, the wood-based panel industry to produce wood-based panels, but also the pulp mills to produce pulp, and actually also the biomass companies producing biofuels like pellets or different biofuels. So these semi-elaborates are further processed in the secondary processing and manufacturing industries. to produce the final products that we are using as society in the different sectors. On the one side, we have products that are oriented to the construction sector, construction, but also furniture and joinery. Then we have all the packaging sector, the paper sector, and also the advanced use of bioenergy, both as thermal energy or power. Very important in the wood sector is that it is a paradigm, this is a very good example for what we call the circular bioeconomy, one of the main objectives of the Green Deal and all the policies, the industrial policies and environmental policies that we have now at the European Union. As you can see here, the forest is absorbing the carbon dioxide from the atmosphere, fixing it into wood, and this wood is used in these logs that we are harvesting from the forest to perform these first products, first semi-elaborates, in the primary processing. But during these processes, we are not only producing these semi-elaborates, we are also producing what we call rests. Rest, not waste, rest of wood parts that are not part of this semi-elaborate. These rests are recovered, are also included in one main use in the primary processing, which is the wood-based panel industry. The semi-elaborates are passed to the secondary processing, the furniture manufacturing, the construction elements manufacturing, the packaging elements, and so on. And they are producing the final products that we are consuming as society. Also, during this secondary manufacturing, we are creating also rests. And these rests are recovered by the primary processing, as I said before, especially in the wood-based panel industry. The final products, as you can see in the slide, they have a life, and after the life, they have either two possibilities. Either they will be recycled and integrated back in the industrial production chain, back to the primary processing, especially in the wood-based panel industry. And some of them, they are landfilling or even also recovered as thermal or energy. This happens in the solid wood chain, but that happens also in parallel in the fiber-based chain in the paper products. So here is another slide in order to clarify what we call the cascade use of wood. That means that all wood, all kinds of resources that we are harvesting in the forest are optimized in the use following not only the qualitative and quantitative dimensions, but also the possibility to enhance all the particles of wood in different uses. So, for example, large dimensions and very good qualities are oriented to produce solid wood or veneer products. Smaller dimensions and lower qualities are oriented to produce particle board products or other wood-based panels, even also fiber-based products like paper. And of some parts of the harvesting and even some rest of the primary and secondary processing industries, we can also use some chemical products in order to achieve high added value products. You see here that a lot of these transformation processes have different cascading material flows, but also they are including both recovering and recycling after end of life. Another aspect that is very important to understand in the wood sector towards a sustainable construction is what we call the added value in the forest bioeconomy. We can produce a lot of products, high volume, but with low value, or we can focus on some products that have not so much volume, but have a high added value. And that is what we call the bioeconomy, the forest bioeconomy pyramid. At the bottom, we have the bioenergy. Clear, we can use all the wood in order to burn it and to convert it in energy, but this does not bring such much added value. It's much more efficient to use the raw material that have enough quality and dimensions to other more added value uses. And better than energy is for sure all the solid wood uses. That means construction, furniture, packaging, based on wood-based panels, biomaterials, bioplastics, biopolymers, and engineered wood products that are now developed in the different sectors of the wood industry. And also on the top of the pyramid, we can see the special products that we can also produce from different parts of the trees in order to have products oriented to the food industry, but also to the farmer and the cosmetics industry with very high added value. So, bioeconomy, cascade use of wood, high rate of recovering and recycling. We are here dealing with the most important industrial sector in Europe, with that includes the circular economy. In this case, a circular bioeconomy, because we have loops of recycling, of recovering almost in all the steps across the different value chains that that perform or manufacture different wood products. Forest bioeconomy is also based on the optimization of the use of the different parts of the trees that we are harvesting. Here you can see a slide from the colleagues of the University of British Columbia in Canada that make very clear that in a tree we can harvest or select some parts of them to do the best products that we can achieve from the different qualities and dimensions that we can obtain from this raw material. So the lower part of the stem is oriented to the saw logs, and the middle part to the pulpwood or to the chipped material, and we have the residual biomass in the crown that could be used for other uses. Maybe we can see it better with this slide that oriented us more to the Mediterranean reality of the roundwood classification towards the different products that we can use in the different sectors, especially in the for construction purposes. So you can see here a pine, a very good pine, in close to here to Valencia in our forest, and in the lower part we see that we can obtain logs that have a minimum diameter of 30 centimeters in the smaller diameter. And that could be used for veneer. In medium parts, we can use the log for sawn timber, for conventional large sawn timber, or even for what we call chipper canter or lower dimensional sawn timber. Well, the parts with a lot of branches that are not so good in quality, but have more than 7 centimeters in the minimum diameter, are used normally for wood-based panels. And then the residual biomass on the crown and in the branches normally are let in the forest or even used for bioenergy uses. If we take a look of veneer, that means the better part of the logs, We need for doing veneer dimensional and quality requirements. The dimensional requirements are lengths of logs that are a minimum of 2.5 meters up to 5 meters and a minimum diameter of 30-35 centimeters. The quality requirements are also very strong and said that we have to have very straight logs with crookedness of less than 1 centimeter per meter length, with taper, that means the relationship between the maximum and the minimum diameter per the length of less than 1 centimeter per meter. We should have at least the sapwood, that means the exterior part of the logs, absolutely free of knots, either through a natural pruning of the trees or artificial pruning through an intensive silviculture, and the hardwood should not occupy more than 50% of the diameter, as we can see here in the figure. What we are doing with this kind of logs after the veneer in the veneer mills is different products that we can use today in construction. You maybe all know what is plywood, different layers that are producing wood-based panels that are very homogeneous in their physical and mechanical characteristics in all the surface. But we are also doing now or producing now laminated veneer lumber, also called microlam, in order to enhance the bending strength of the model of rupture and use it also for structural elements. Not so much in Europe, but in the United States and Canada, paralam, that means parallel strand lumber with parts of veneer can be also produced for structural uses, for beams, that you can see also in the figure. And today, I-joist combined with this, for example, LVL or microlam in the heads with different panels in the middle. If we go further with our classification of roundwood towards products for use in sustainable wood construction, we can go to the conventional sawn timber. That means the large sawn timber. The requirements, the dimensional requirements for such logs in order to be used for sawn timber for construction purposes should have a minimum length of 4 meters and a minimum diameter of 30-35 centimeters. The quality requirements are a crookedness of less than 3 centimeters per meter, taper of less than 1 centimeter per meter, and the knots are very important because the knots influence directly the final quality in order to have better or worse structural classification of the sawn products, of the sawn material. Large sawn timber products for construction are developed and produced in sawmills. Sawmills have different sawing programs in order to obtain either planks or boards. Planks are sawn products that have a thickness of more than 50 millimeters. Boards are also sawn products that have a thickness of less than 50 millimeters. Planks are more oriented to construction purposes. Boards are oriented to other uses, for example, in joinery, in furniture, but even today also for construction purposes, as we will see. Here is a typical classification of thickness and width of different sawn products oriented to construction. And well, you see that the thickness can begin with 12 millimeters, but we could have boards of 12, 16, 19, 22, 25, up to 50 millimeters. And we have then planks of 50, 63, 75, which is very common, or 100 millimeters in thickness. So the main classification of sawn timber is done by the thickness. So related to the thickness, we have also the width, And you can see very typical products that we are using also in construction. For example, very clear is the plank of 75 thickness by 150 millimeters width. The lengths are variable, but normally they are directly depending on the design of the different buildings. Large sawn timber products for construction are normally classified by the structural strength classes. Here you can see the table of the classification of strength classes of softwood following the European standard 338. The strength properties, the strength classes, sorry, are C14 to C50, C14, C16, C18, C20, 22, 24, 27, 30, 35, 40, 45, and 50. What means this 14 to 50? That means the bending strength, that means the modulus of rupture in newtons per square millimeter, that means in megapascal. So if we want to classify sawn timber to use in construction, and we need for our solution with our structural solution at least a minimum of 30 newtons per square millimeter of bending strength quality, we have to use C30 or even more. Normally, the wood which is classified for these strength classes are marked with different marks with the logo of the certification body, the standard reference, and also which kind of strength classes it is, and the species that the wood species that are in this package, in this group of sawn timber. So if we go up in our classification of the roundwood, we see that we have not only very large and good dimensions for veneer, and also very good dimensions and then qualities for conventional large timber. We have also smaller dimensions that we can also use as small sawn timber. For producing small sawn timber products, we have as dimensional requirements a minimum of length of 2.5 meters and a minimum of diameter of 15 to 20 centimeters. The quality requirements are also a crookness of less than 3 centimeters per meter length, a taper of less than 1 centimeter per meter, and the knots are the main structural element inside the wood that influence the final quality. And here, not for the final construction elements, but for the structural classification of the lamellas of, for example, glulam, or even for packaging uses, for example, for pallets. The small sawn timber products are performed in sawmills that, that are using traditional machines, like you can see on the left side of the figure, parallel saw blades that are producing all the slabs or all the boards in a continuous way. Or we have also the chip counter or the chipping machine, as you can see in the right side, in order to profile the log and then to sew it with the different saws. Well, normally the small sawn timber products are boards, and boards are around 20 millimeter thickness, can be a little bit more or even a little bit less than this thickness. For what uses are we are performing with these boards? Well, one very important use in our country, in this case in Spain, but I think everywhere now in Europe, is pallets. Pallets are by far very important products of this kind of, let me say, small dimensional sawn timber. And we have increased during the last decades our production in pallets very, very drastically. So we here in Spain are producing around or even more than 600 million of pallet units per year. As you can see, they are the composition of this kind of pallets are boards or slabs that have a length of 1.2 meters, that have, if you want to classify them and to certify them as Euro pallets, so as high qualitative pallets, at least 20 millimeters thickness, and the width, well, depends, but it between 100 millimeter and 150 millimeters. So that are the typical sawn products that our sawmills are producing today, with softwood, with pines, with Mediterranean pines that we have here in the Iberian Peninsula or in the southwest part of Europe. That is good because a lot of sawmills that are small and medium-sized enterprise, more of them located in rural areas, are surviving thanks to this activity. So it's a product with not so much added value, but with a possibility to put it in the market and to, let me say, survive the sawmilling business. But with this kind of boards, we are able also to develop today what we call engineered wood products oriented to construction. And here we have two star products. On the one side, that is the laminated glue timber, or what we call glulam, as you can see on the left side of the figure, or we have the cross-laminated timber, CLT, on the right side of the figure. Glulam is used for large products, gluing in parallel, in grain parallel, different lamellas or boards, as you can see here, of pine, very used for doing these products, and CLT, that are different layers, cross-laminating in the grain orientation the different layers, and having always 3, 5, or 7 layers, so that the first and the last layer are in the same grain orientation. And through the cross-laminating, we are also improving what is or homogenizing the structural behavior in all the panel. So with CLT, we can prefabricate also different structural solutions, as you can see in the lower part of the right side of this figure. So, following our classification of the roundwood, yes, and not having enough quality and dimensions for sawn timber, we are coming to the classification of timber for wood-based panels, roundwood for wood-based panels. Here, the dimensional requirements are much more easier. The minimum diameter should be, in any case, more than 7 centimeters. And the length should be more than 2 meters, normally 2 to 2.5 meters. The quality requirements, all qualities are accepted to the manufacturing of wood-based panels, but we have to avoid rotted wood or decayed wood. So the wood-based panels can be supplied by roundwood from the forest, but nowadays, they are also supplied by the recovered or recycled wood coming from the different primary processing and secondary processing, even recycled final products after end of life, as you can see here also in the figure. Recovering and recycling is very important for some of other wood-based panels, especially for the particle board of chipboard, which is one of the main boards that we are using, not only in construction, also in furniture or in joinery. Here you can see the most important wood-based panels, the chipboard or particle board. I know that is one of the main panels, and by far the panel that is more used in the whole wood sector. But we have also the medium density fiberboard, all the fiberboards that are also used for different uses, especially in furniture and in joinery. Both chipboard and MDF were traditionally developed and manufactured here in Europe, but since 20-30 years we have also integrated in our wood sector the production of oriented strand board, also called OSB, that you can see on the left side of the figure, the slide. Oriented strand board that was used before in Northern America, and nowadays is used more and more in construction, also replacing especially plywood due to the lower requirements of quality that OSB needs in comparison with the high qualitative requirements that are needed for the manufacturing of plywood. That means OSB is a cheaper material, but with very important and very interesting mechanical performance. Additionally, today, the wood industry is also developing different composite, mixing different materials, for example, wood plastic composites, and for special uses, especially for uses in outdoor, taking the advantages of wood, but also from other materials in order to make wood more stable and more durable. So, taking all this into account, in our project, in the IMIP project, we came from the starting point to analyze what kind of resources we have in our area, in our SUDOE area, and what we can do in order to make an autochthonous solution or even smart sustainable construction based on materials that we have here at our disposal. And we thought that our sawmills are sawing especially softwood in small dimensions, as we saw before, for pallets that can be used for cross-laminated timber. And these autochthonous species, softwood species, are especially Pinus pinaster, Pinus alepensis, Pinus nigra, Pinus uncinata, and other pines that we have here in the Iberian Peninsula. On the other side, we can also improve or combine our CLT with these autochthonous species, not with the dominant species we have in Europe, like Pinus sylvestris or Pythia abies, that means Scotch pine or spruce that are dominating the market, but replacing them by our Iberian pines. So we can combine this kind of CLT with OSB that we are also producing in different mills in Europe, in order to enhance the mechanical behavior of our construction elements. And last but not least, we can also include cork as a very interesting and very good insulation material, not only thermal insulation material, but especially acoustic insulation material in expanded dark cork panels, integrating them in different layers between OSB and or CLT. That was the idea and the starting point of the IMIP project, and other lessons will present the different results that we have achieved with the different sandwiches and panels and pilot actions that we have developed with these materials. Also, some reflections about the trends in wood construction in Europe. said that actually the current situation and the forecast is that we have and will have a continued and sustained increase in the construction activity in Europe, but more accentuated in rehabilitation, also in public and civil building, than in the new residential construction. You can see the figure down from the source of Euroconstruct 2020, where the increase in new residential construction is lower than in all what are the activities related with rehabilitation or even with civil building or even with public building also. On the other side, in this mega trend of having increase and sustained increase in construction activity in Europe, we see that wood continues to increase its market share, both in structural elements and also in joinery or carpentry, like doors, windows, flooring, or cladding. Engineered wood products as structural wooden elements continue to increase their production and consumption in Europe, especially glulam, cross-laminated timber, and also I-joist. That are the more important engineered wood products that we see that are increasing their use, the market in Europe. And if you see on the right side, the more important companies producing CLT, cross-laminated timber, are growing and growing year after year. Well, that is the trends that we have in construction, but sustainable construction today means also tackling climate change. And building with wood is a very good example to tackle climate change. So, wood installed in long-life products, that means in buildings in Europe, are now storing more than 16 million of tons of carbon. In our area of SUDOE, that means in Spain, Portugal, and South France, we have even more than 10 millions of tons of carbon fixed today in different wood products in our houses. There are 8 reasons that are very important in order to understand how building with wood is tackling climate change. The first is that we are working with a renewable raw material based on sustainable forest management in comparison to other materials that are not sustainable and that are not renewable. The second is that the industrial use of wood stimulates forest management, that means reforestations and the conservation of forest ecosystems. There, where we have a good forestry wood chain, in which the foresters, in which the forest owners are becoming revenues from the production of wood, forests are maintained, forests are managed, forest ecosystems are conserved and protected. The third reason is the carbon sink for storage of carbon fixed in wood by the trees. The fourth is the low greenhouse gases emissions due to the low carbon dioxide emission of the industrial and logistic processes, based also in the absolutely and excellent relationship between the low weight of wood and the good mechanical properties and the possibilities of prefabrication. The fifth reason is that wood is a recyclable raw material, and also the wood sector developed today a lot of recycled products, especially the wood-based panels, in circular economy, as we have seen at the beginning of the presentation. A sixth reason is that energy recovery of waste by replacing fossil energy, that means thermal processes in woodworking industries following the cascading use of wood. Seventh is that energy efficiency in buildings have with wood is due to the excellent insulation properties that wood and wood products have. And last but not least, what we call the triple effect of substitution of other construction materials. That means replacing materials with high carbon dioxide emissions, for example, plastics, but also steel, aluminum, and even concrete, have 3 effects that are very important to be aware of them. The first is the reduction of emissions in production and logistic processes. The second is the increased recycle rate. And the third is the lengthening of product life cycles. And following cost action, a coordinated research action that we had between year 2001 and 2005 in Europe, coordinated by Professor Rüwald in Hamburg in Germany, we came to the result that the total carbon dioxide saving from combined carbon store and substitution effect in 1 cubic meter of wood was 0.9 tons of carbon dioxide through direct carbon store and 1.1 tons of carbon dioxide through this energy substitution. That means if we are using 1 cubic meter of wood in construction, we are saving 2 tons of carbon dioxide emissions. Some facts that are also supporting this contribution to climate change or this sustainable wood construction is that wood is a netto storage of carbon in comparison with other construction materials, in comparison, for example, with plastics, with PVC, or with metals like steel, like aluminium, but it's by far the more emitter material, but also with minerals like bricks or like concrete. As you can see here in the figure, wood is the only product that is a netto fixer, and all the other materials are more or less emitters of carbon dioxide. That could be seen better here if we analyze the whole life cycle of the different materials. And all what are wood products like sawn timber, like plywood, laminated linear lumber or LVL, chipboard or particle board or fiberboard are all fixing or emissions of carbon and not emitting during the entire life cycle, in comparison with the minerals, for example, lime or bricks or concrete, that are emitting, not so much, but emitting, or in comparison with the metals. That means here are the examples of steel and aluminium that are clear emitters of carbon dioxide during the entire life cycle of the different construction products. If we analyze the time of use of one building, here is another survey done by at the European level, comparing what is a wood-based house in comparison with a house of concrete and steel. And we see by far that in the use of the different energy sources, what we need on energy consumption in these two different construction possibilities or houses, the house with concrete and steel is emitting 8-10 times more than a house based on wood. Okay. We're coming to the last point of the presentation, and after analyzing what are the key facts of sustainable wood construction, what are the challenges? What are the research challenges in our area in order to improve the use of wood in sustainable construction in the SUDOE area? That means in the southwest part of Europe. Well, we have analyzed also in this, during the development of our IMIP project, what happens with the research in wood and wood in construction in Europe and in the whole forestry wood chain. So we have seen that years ago, that was developed what we call the strategy research agenda for the forestry wood sector, with a lot of influence of Northern Europe, but also the different European research associations and the industrial associations. This strategy research agenda was a kind of lobbying in order to, well, to explain to the Commission what are the main challenges for the future research in Europe. And after having different framework programs of research, for example, Horizon 2020, but also the former framework program 7, the results that we could see in the research database of the European Union is that the revenues of the funded project were very unbalanced in the different parts of Europe. So Northern and Central Europe concentrated more than 85% of the funds, and South Europe only 5% of the funds. So Sweden, Finland, Austria, Denmark, Germany, UK, even Portugal, as a small exception, are concentrated quite a lot of money in wood in construction research, or in wood in general research. And South Europe is very, very underrepresented. Italy, Spain, Greece, Croatia, and France, somewhere in the middle. So, after taking these results into account, we see that we have what we call the forest paradox in South Europe. It is clear that the Mediterranean forests are very important for Europe. They are key European ecosystems for adapting climate change, but also for the mitigation of climate change, for improving the water quality in all the Mediterranean basin, to increase and to maintain, to conserve the biodiversity, which is very, very important in the Mediterranean in comparison with other parts of Europe, and the landscape. But that is on the positive side. On the negative side is that we have in our forest activity very little capacity or very limited capacity for valuation and insertion in economic flows. That means the rate of harvesting, the rate of management is very low in comparison with other parts of Europe. And if you see that in the lower part of the slide, we see these blue areas are with the lowest harvesting intensity, with a lot of unmanaged forests that are not able to supply with good raw material to the local industry. The results in the last decades today are that we have in the Mediterranean area, in our SUDOE area, large areas with abandoned sustainable forest management. That means with a lot of unmanaged forest. That is also depending or close related with the rural depopulation of large parts of our countries. Additionally, we have high cost of prevention and suppression of forest fires, which are the most important natural disturbances we have in our part of Europe. And we have insufficient public resources in order to invest in this prevention or suppression activities against forest fires. So no revenues from the wood production in order to reinvest them in the maintaining and the conservation of our ecosystems. Well, that has a difficult solution, but the solution is oriented more what we can see in the new policy at the European level, derived from the Green Deal and all the packages, directives, and legislations coming from the Green Deal, and also especially from the new European Forest Strategy, which was developed for last year towards 2030. And here we have two solutions possibilities. On the one side is the forest bioeconomy. That means the enhanced use of wood for building, that means for construction, but also for living, that means for furniture and other uses of wood. That is one thing, one solution line, and the other is to put into value also the ecosystem services, that means especially the carbon offset mechanisms, but also the quality of water, the quality of the landscape, biodiversity, and so on. But especially the carbon offset mechanisms as an active policy to mitigate climate change and to reinvest in the carbon fixation activity in the forest. So to move in this direction, we have to change our mind and to go ahead from a linear forest wood chain to a more circular forest and wood bioeconomy. That means for a typical industry of natural resources, to take it off, to make, to produce, and to dispose, to a circular forest and wood bioeconomy as we have seen it before. So we are going in this way, and the wood sector is doing it in a right orientation. So the vision is to have a leading sector, the wood sector, especially the wood construction sector, should be a leading sector in decarbonization and compensation. We have also to improve and to enhance advanced materials, advanced processes and products, especially for this sustainable construction. As an example is here our IMIP project. We have to improve our recycling systems to optimize the logistics, both internal logistics in the companies, in the factories, in the industries, but also external logistics in the construction field. Also, we have to put in value the health and wellness products and services in our building environments, in our building solutions. And we have to integrate also the information and telecommunication technologies, that means the digitization. The decarbonization in wood construction should be oriented in three main axes. On the one side, the sink, that means the capacity of forest to capture carbon dioxide from the atmosphere. The second is the storage, the carbon storage in the forest ecosystems and also in the wood products. And the substitution is also important. The sequestered carbon in wood products, the avoided emissions through replacing other emitters or emitting materials like metals or minerals, like steel, like aluminum, like concrete. So, and the vision in order to move against an effective research, technical development, and knowledge transfer between academia and industry, and between and also professionals in the construction sector, is to work in sustainable forest management, more the forest engineers, in increasing the harvesting rate, which can also be positive to break the rural depopulation and to contribute to the rural development, to innovate in construction in terms of materials, products, as processes, as we are doing in this project in the area of bioeconomy that is more related to the storage of carbon, but also in contribution to the transition, to the ecological transition, in order to substitute, improving the substitution of fossil materials and products through wood-based materials. The challenges for our research today in different research groups working with wood in Europe is the climate change adaptation, addressing growing risk related to climate change like forest fires, pests, snowfalls, and so on, to overcome administrative and technical barriers to increase the rate of wood use, especially in construction, beginning with the public building, to break the ceiling on value generation for forest products, not only in construction, maybe also in packaging, to improve transparency in the wood market and carbon offset mechanisms, to mobilize financial investment in value chains of forest products and service, integrating also public support, and now we have a lot of European funds to support that, to clear and quantify the substitution approach to help make decision about enhanced use of wood in construction. And also, I will say that it's really important to improve the acceptance of wood by the citizenship, especially by the urban citizenship. So, I'm coming to the final slides. What are, after all this, what we have said during the last minutes in this lesson, the real research challenges for 2030? Yeah, we have a globalization in which we are dependent on the product imports, especially in these areas of Europe, like we are, depending on not having so much a harvesting rate in the forest, but having an important wood sector. These globalization impacts are that the prices of wood products are set in international markets based on the performance of the strongest competitors. In the absence of local supply markets, we lack competitive advantages even in low value added products. So we are coming to a net import of wood products. But with innovation to improve the quality of our products and also our services in wood in construction, the challenge is to have a more profitable wood sector with high value added products and services. In wood in construction in our area, that means enhancing our resources in order to make better prefabrication and better products, for example, cross-laminated timber with our autochthonous species, alternative treatments in order to improve dimensional stability and durability of our wood elements in construction, especially also for outdoor uses, integrating cork as insulating material, not only from the thermal point of view, also from the acoustic point of view in our buildings. And also, as byproducts and accompanying the sustainable wood construction, using in our buildings also advanced biofuels, also wood-based biofuels, and non-timber forest products for other uses in the agri-food, in perfume, cosmetic, pharmaceutical industries, and so on. That brings value. And this all in a transition from a traditional wood sector to a sustainable wood sector based in sustainable wood construction in the 21st century. And to do that, we have to develop more research, applied research and technological development, and to transfer the results in a very good way, both to the prescriptors, that mean architects, but also building companies and engineers, but also to the society as end users of the construction products. And here we have, in this transition, two main drivers, the emerging, what we call the emerging drivers or the enabling drivers. The emerging drivers are that we have now a good legislative framework on sustainability. Economic crisis now, after the pandemic, COVID pandemic, and also now with the Ukrainian war, brings market instability. But we have major markets for current products. And also we are in a situation of changing competitive advantages and also having different or evolving value perceptions about natural resources and about wood-based materials for wood in construction. We have to focus in sustainable construction. We have also to use the prefabrication possibilities and also the trends of do-it-yourself, which with wood is much more easier than with other materials. And we have also, as emerging drivers, the new consumption patterns, that means environment and health. On the other side, we have also enabling drivers, base and potential of renewable wood resources, technological advances, that means new products and resource efficiency, and a favorable environment that are synergies between climate, energy, environmental, and urban policies. The access to financing, we have now a rate stability and venture capital, and we are also included in megatrends that are very positive in order to make this transition to the classical wood sector to the sustainable wood construction in the 21st century, that are energy efficiency and climate change mitigation, digitization, well-being, and health. So I hope you can enjoy other lessons related to the different achievements and results of our project. And I hope this lesson can open your mind in order to understand what is the transition to a sustainable wood construction environment, what we need in our SUDOE area. Thank you very much for your attention. And please do not hesitate to go to our website. And you can see here the website of our IMIP project. And you can have there in different languages all kinds of information about the products we have developed in this project. Thank you very much.